probability of A and B. Okay, that was the one. You want to find the probability of A and B. The result is going to be called multiplication rule. So we talk about the events. If you get two events in which the probability of one of them nothing to do with what would happen to the other one, these events are going to be called independent. If the events are going to be independent, then the probability of A and B would be simply probability of A times the probability of B. This formula can also be extended. If you have 3 events, 4 events, then you just multiply them together. You see, if you get 4 events, it's going to be probability of the first one times the second one, the third one, the fourth one. So that would be very, very popular case. So we give you a couple of examples. Now what we're going to do, we are going to take what would happen if these events are going to be dependent. When the events are going to be dependent means the probability, likelihood, chance of getting one of them depends on what would happen to the other ones. So in that case, we have a new notion. That notion is going to be called conditional probability. Okay, the conditional probability. So we check this one first, and that will take us to the general rules for the multiplication. Okay, this is a very straightforward argument, and when they want to express the problem, they are going to tell you that they are talking about conditional probability. Okay, so let's give you the definition of conditional probability. Okay, are you ready? This is it. Suppose you have 2 events. Okay, suppose we have 2 events. The events A and B, all of them are given. Now, the conditional probability of one of them, you see the conditional probability of B is going to be the probability that B will occur under the condition, under the assumption that something else is already occurring, that something else is A. So the conditional probability of B is going to be the probability that you are going to get the B, given that the A is already happened. Okay, so let's define it. So the conditional probability of B, of an event B, is the probability, is the chance, or is the probability that you will get the V, that the event B occurs under one condition, under the assumption, that A is already happened, that the event A is occurring first, has already, this event has already occurred. So this is going to be the conditional probability. Okay, this means, the probability that I will buy a new car, and there is that if I've already got a raise in my salary. So in that case, this chance of buying a new car is kind of conditional. The condition is I should get the raise first. Okay, this A, we are going to call it the given event. The event A is going to be called the given event. Always we denoted by a given event. That's why in alphabetic order, I use the A for this one, then the B, and the conditional probability, and the conditional probability of B. You see the expression of B given A. B given A. Of B given A is going to be denoted by, is denoted by, that's a notation, probability of B given A. You see, you start the B and a small, vertical line, and then the A. When we are going to read it, okay, this is the way we read this one, which is red. Okay, which is read as, this is the way we call it. We say the probability. The probability. Okay, the probability of B given A. So always the given one, the first event, we are going to call it A. The second one is the B, but the conditional probability is this one, probability of B given A. So when the problem is given to, they just use exactly the same expression when they ask you to find it. They say probability of B given A. So you have to identify your given result. And this given one would be given to you in any statement. So in order not to be confused, always use the A for the given events, B with the whatever you want to find. Okay, that's a notation. Any question? Now we have a very nice formula to take care of it. And the formula is going to be, this is it. We call it conditional probability formula. That is going to be the case, conditional. Okay, what is going to be conditional? Conditional probability rules or formula. And this is going to be a formula. Probability of B given A. Probability of B given A is equal to, you get a fraction bar. On the top is probability of A and B divided by the probability of the given one, A. Okay, probability of A and B on the top, but divided by the probability of the given one. Any question? Now, if you they are all numbers, are going to be 3 numbers. If you cross multiply, give you the formula that you need. Note that if you cross multiply it, you get something, but you get probability of A and B is equal to probability of A times it by probability of B given A. You see, B given A. This is going to be the general multiplication rule. Or you can say it's a multiplication rule for the dependent events. They call it multiplication for dependent. And always you can write this one first, okay, then depends on the problem, you can change it. So officially this is multiplication rule. Okay, multiplication rule in general. Or some people like say that multiplication rule for the dependent events. Dependent events. So that's it. Probability of A and B is equal to the probability of A times it by probability of B given A. That would be the general multiplication rule that we use. And it is obvious that if A and B are going to be independent events, then this probability of B given A would be the same as probability of B. Because when they are independent, it doesn't matter what would happen to the A. Okay, in that case, this would be equal to each other, and you get the formula that you have. Okay, so I make a note for you here that if A and B are independent, okay, if they are going to be independent events, then there's no condition on the B. Probability of B given A is going to be equal to the probability of B. Because the probability of one of them happening is nothing to do with the other ones. So in that case, these two are going to be the same, and then you get your original formula that you have, okay? And so you get the fact that the probability of A and B is equal to the probability of A times probability of B. So it's safe to write the first one. Then if they are going to be independent, automatically you are going to be end up with the probability of A and B. Okay? Because there is not going to be anything, anything in between in that case. So the case that we did have the other day, that drawing a card, remember? Drawing a card from a deck of cards. Remember, we draw two cards and would like to get the king. So we talk about it, two different cases. The case that you take the first card, but you don't return it, and you return it or replace it. If you replace it, the event's going to be independent, and we did use this formula. But if you take the first card, you have a check it, you find out it's a king, you may keep it in your pocket. And when you go back, then this is going to be without replacement, and then you have to use conditional probability formula because something else has already happened. This is going to be different cases that we're going to have, and we're going to investigate it in a minute. Okay, any question? So make sure you add these two formulas to your collection. That would be used for one of the problems for your next test. And this is going to be the multiplication rule in general. So both of them are going to be used. The first one is very obvious. We are not going to miss it because of the expression that they are going to use. So I give you one for the first one and one for the second one, and then we are done. Any question? So let's see how they are going to express the first question for us. Okay, a survey would be given to you, and then they ask the question. So it's a very typical example. In this problem, we ask 100 people, about this question, that whether women should be permitted to take part in combat. You know that it's already been solved, and now this is a law. But this is an old survey. So let's write it down and then discuss it. A recent survey. Recent survey asked 100 people. Asking 100 people if they thought or believed if they thought a woman in the armed forces should be permitted. Woman in the armed forces. Okay, the armed forces. Armed forces should be permitted to take part in combat. Should be, okay, should be permitted to take part. Take part in combat. So that is the question. Now the result is summarized here. We have the following result. The results of the survey are shown here, for example. So this is the table that we are going to have. So we talked to 100 people, we divide them into two groups. The gender were male and female. Okay, some of them said yes. And some tell us no. Okay, that doesn't know here. Okay, we get for the male, the answer was 32 said yes, and 18 said no. For the female, 8 say yes, and 42 said no. So going to be the one, and you can extend the table in case you need it. So we get a total. So over here you get a 50 and 50. Okay, 50 and 50, and if you want to extend it here too. So these total are 40, 60, and 100 in case you want to use them. Okay, so this is the given information. Now what's going to be the question? I have to answer two questions. The first part is that we want to find a, let's say, before getting to the second part, it's going to be, we would like to find the probability. We pick one person out and we ask this question. Find the probability. Okay, probability that, what is the probability that the respondent, okay, the probability that the responded answered yes, given that, okay, given that the respondent, given that the respondent was a female, You see the way they are going to express the questions automatically will tell you that this is a conditional probability because the probability is something given that. So you better label it because you have to write the formula for us when you want to do it. The labeling is going to be always called the given 1A, because which is the case that in the formula. So this given, as soon as you see the given, the rest, given that, you call this one A, and the other part of the problem would be B. Okay, so your formula is probability of B given A. You see, this is it. B given A, and then you'll be able to substitute the result. But this is the way you organize it. You always use the A and the B to get the formula. Okay, that's the first question. Any question? We have another one, then we do it. The second part. The second part is that the respondent was a male. So the respondent respondent was a male, given that the respondent says no, given that the respondent say no, that is, or said no. Again, the second part is a probability, conditional probability question. The part that's going to be given that you call it A, you see, you call this one A, and the other part is the one that you are going to call it B. You write the formula and the probability, a straightforward problem, and you answer the question. So read it carefully that to identify these two correctly when it's going to be given to you. Otherwise, the rest is going to be easy. Okay, any question? Are you ready? Yes, so I'm going to go to the next page to take care of it. So I will talk about the formula. So you write the formula probability of B given A. Then from the table, you can find the probability and put them together. Remember, the total number is 100 people that we're going to have, and you have the information regarding those numbers, okay? So the solution for the first part. Solution, part 1. Your formula is clear. The formula is probability of B given A. B given A is equal to probability of A and B, always divided by the probability of the given one. And both probability are out of 100, so this is how you're going to find it. You get a fraction on the top, fraction on the bottom, so it's going to be 100 and 100. So you have to find what is A and B means. Okay, if you go back to the problem and you read it, you see, that is your A and B in the first part. You read them together. So what you want for that one, you want to know what's the probability that the respondent answered yes, and the respondent was a female. Okay, yes, female. Go to this one. Okay, this is it. Female, yes. Female, yes, you have only 8. Okay, so the probability of A and B would be 8. Okay, read these two together. Probability that the respondent answered yes, and she was a female. Yes, female, it's going to be 8. So that would be 8 over 100 that we're going to have, okay? So this is 8 over 100. Probability of the given one, what was A? Category of A is that the respondent was a female. The total number of the females is 50. Okay, so 50 over 100. So it's going to be 50 over 100. Any question? So just use these type of notations, and the rest is going to be straightforward. These 200s would cancel out. It's a fraction. So you're going to have the 8 over 500, 50. Okay, you can use your calculator, or this is going to be what? If you multiply the top and the bottom by 2, is a 16 over 100, which is 16%. Okay, so you can simplify it if you like. If you don't want to give us a percent, you have to simplify. It's going to be 4 over 25, or it is 16%. So the probability of the first one, B given A, is going to be 16%. So that's the first part. Any question? So, just use the proper notation. There's nothing to worry about. That's the first case. And the second one, the same thing. You already identified the A and the B. So this is going to be probability of B given A again. Same notation, use it. So that gives a probability of A and B divided by the probability of the given one, which is A. So check to see what is the condition now. The condition is A and the B is, see what's that, the probability. Let's get this one again. You see, if you read them together, the respondent was a female, and the respondent say no. So male, no, male, no. So we got 18 male who said no. It's going to be 18 over, okay, 18 over 100, okay? So this would be 18 over 100. And the second one, probability of A, what was the A in this case? The A is the fact that the respondents say no. Total number of the no is 60. So it's a 60 over 100 or out of 100. So that gives 60. So it's going to be 60 out of 100. So the hundreds was canceled out. We're going to have the 18 over 60. Simplified by 6, that give you, okay, that give you 310, which is the 30%. So this is going to be equal to the 30%. So in this case, the probability of B given A is simply 30%. And you're there. Okay, so it's an easy question, but make sure you read it carefully when it's going to be given to you. Okay, any question? So that's a type of conditional probability question that we're going to have. They cannot change it, nothing. And sometimes all the probabilities are given already, but you have to design the formula to get these numbers done. And this is probability. Remember, it must be less than 1 or less than 100% when you form this quotient. If you get anything else, this means you made a mistake. Okay, that's a type 1. Okay, any question? Now the type 2 is how we're going to connect it to the multiplication rule. And the following is a very famous problem that we have for this format. You have a couple of them in your book. You see one in your next, what's that? Take-home one, practice test, or your test 2, and your next take-home, that they give you a take-home for each test. So you will see both of them over there. Okay, this problem is like the one that we did. They call it the urn problem or the box problem. That's it. We have a container. We have an urn. Okay, contains or a box. That would contain 17 balls. Like a deck of cards. 17 balls. They are going to be all the same except the color. So it's going to be identical in every aspect except the color. Every aspect except the color. So they are the same size, everything, but you have different colors. Okay, so the situation is that we have 6 red balls, 6 red balls. Okay, 6 red and 8 green. Okay, 8 green and 3 blues and 3 blue balls. Okay, if you add them together, that should give you that 17, the total number that we have. So this problem would be divided in 2 parts. The first part, what you do, you are going to draw 2 balls. You draw 2 balls, but with the condition that you check the first one and you replace it and you get the second one. That's the first case. The second case, so the first case would be the case with the replacement, but you repeat this procedure again, but you don't replace the first ball. Okay, so that's the situation I'm going to have. So you draw, okay, you draw 2 balls. draw two balls from the N box. Okay, but that's the point that you have to consider, but replace. As soon as they say replacement, this means that the events are going to be independent. But replace the first ball, replace the first ball, replace the first ball before drawing the second one, before drawing the second ball, the second ball. So this means you did it with replacement, so the situation is going to be independent events. So they ask you to find the probability. Okay, find the probability. And find the probability that the first ball, the first ball is red. The first one is red and the second one is green. And the second ball is going to be green. So that's the first question. Okay. And the second part, they say, oh, we repeat it again, but this time we are not going to replace the first ball. We check the color of the first ball and we keep it. And then we go back and we pick the second one. So you change the game, rule of the game. So in that case, the event's going to be dependent. Okay, so the second part, these type of problems will have always the second part. So the second part is that repeat part one, repeat part one, part A, but don't replace, okay, without replacement, but do not replace the first part, keep it. Do not replace the first part before drawing the second one. Before drawing the second part. So basically, this case is with replacement. Okay, this case is going to be with replacement. This case is without replacing, without replacement or without replacing. This would be with replacing. If it is going to be, you know that. If it's going to be with replacing, so your events are going to be independent. So in the first part, the events are going to be independent for your note. And the second part, the event is going to be dependent. So you have to use two different formulas. The formula is going to be the product rule because it's an and combination. Okay, it's going to be and combination, but the first part, you choose the multiplication for the independent event, which is A times B, probability of A times probability of B. But in the second part, you have to use the conditional probability format. So this is going to be the solution. The solution for the first part. You have to explain it. You have to tell us that the events are, in this case, the events are independent because the probability is going to be unchanged. Okay, so your formula is, you want to find the probability of getting what? Probability of getting a red and green. Red and green ball. This is the question. So since the event is going to be independent, so this simply would be probability of getting a red one times the probability of getting a green one. You just substitute the total number of the balls 17, but the red, you have 6 out of 17. So it's going to be 6 over 17 times it by the greens. Okay, you have 8 greens. It's going to be 8 over, okay, that's it, 8 over 17. You cannot simplify it, just multiply them together. So 6 times 8 would be 48. 17 times 17 would be 289. You can change it to the percent by using your calculator. So it's going to be almost 16.6%. So that gives you the probability. So it's almost 17% chance, 17% chance that you get the situation that the first ball is going to be the red and the second one would be green. Okay, any question? That's the first part. But for the second part, you take the first ball and you replace, you don't replace it, you keep it for yourself. And you go back. In this case, that would be conditional probability because something else has already happened. That something else is the fact that you just kept one of the ball. So you have to explain it again for us that the events, okay, the events in this case are dependent. So your formula would be changed a little bit. So again, you want to find probability of getting what? Getting a red, okay, getting a red and a green. So this time it's going to be probability of getting a red, which is the first ball, but remember, you keep it for yourself and you go back. Times it by the case that the second one would be green. Yes, the second one would be green, knowing that, okay, given that you already got the red one, you see, that's one. It's like A and B, probability of A and B would be probability of A times the probability of B given A. So the second part is going to be conditional one. Any question? So you explain it with the formula and with your, okay, with the expression over here for the test, you know. Okay, if you write the formula, we understand that you realize that they are independent. And if you write this formula, we understand that you realize that they are dependent, okay? So just make sure to give us the formula. But the rest is going to be straightforward. Red would be unchanged. It's going to be 6 over 17 times it by now the second one. The second part is going to be, see, you kept one of the reds. So the total number is not going to be 17, it's going to be 16. And since it's a different color, probability of getting the green, the number of the green is going to be 8. So it's going to be 8 over 16. You got to be careful because if this was the same color, if you want both of them to be red, then this would be 5 over 16. So in this case, the total number would be 1 less from the 17 to the 16, and the top is going to be 8. So that's the probability of G given R, or probability of getting a green ball, given that you already got one red. Okay, any question? So you simplify it by 8, 1, 2. If you multiply the leftover, it's going to be 1 times 6, 6. And that would be 2 times 17, which is, okay, that give you, oh, you can simplify it further. You see, these 2 and the 6 can also be simplified. So we can also simplify 2 and the 6. By 2, that would be 1. By 2, that would be 3. So the final answer is going to be simply, okay, so the final answer is going to be equal to the leftover on the top is 3, on the bottom is 70. And you can use your calculator. That would be something like 17.6%. And that would be the probability for the second part. Okay, probability of getting the first one would be the red, the second one would be green, with the fact that you did it over here without replacing. So just keep the ball to get back. Any question?
I have a question.
Professor, I have a question.
Yes.
Sorry, go ahead.
Go ahead. No, it's okay. Go ahead.
Professor, if in this scenario where you're trying to select the red ball first and you select, say, a green one, do you not even
It doesn't matter. It
consider the
doesn't matter.
problem? It doesn't matter. The
Doesn't matter.
probability is 0, or you don't even do the problem.
If you switch it, you mean you switch the formula here?
No. In other words, the condition here is I have to get a red ball and then I have to get a green one. But obviously, you could also select a green one or a blue one first. And my question is, what happens in that scenario if you select a ball that's not red? Is the entire equation irrelevant, or in other words, it doesn't meet the condition?
No, it doesn't mean the condition, because the ball in question are going to be red and green. Okay. So the way they express it is find the probability that, you see exactly, they tell you, find the probability that the first ball is red. You see, you have this one. Find the probability that the first ball is red and the second one is green. So that's why your probability would be R and G. Because you don't have the option over here. You see, that's going to be the one. So the exact question is the P of R and G. So you want the first one to be red to get these numbers over here. Okay. So the probability that the first part is not red is not our concern, because you want to find the probability that you get the first one to be red. If that makes sense? Okay. What was the other question?
I had a question about the simplifying at the very end. If we don't simplify those two, like if we didn't simplify 6 and 8 into 3 into 17, would that affect our answer, or is that just an extra step?
No, because your answer must be given in simplest form.
Oh, okay.
So if you don't simplify it now, then you have to simplify it later.
Okay, got it.
See, because in that case you get 6, for example, over 34.
And then we simplify by dividing by 2? By
dividing by 2, yes. That gives 3 over 70. Yeah, you can stay with the fraction, but it must be in simplified form.
And then I have another question, I'm sorry.
Yes. Okay.
So at the very end on part B, how do we simplify 8 into nothing? Like, I'm not seeing how it just went from 6 to 8 and with the other ones to 3 to 17.
You see, we have 8 over 16 first, okay?
Mm-hmm.
So 8 over 16 would be 1/2. That's going to be the one. So it's a multiplication of two fractions. You see, that's what you have. So you can simplify anything from the top by anything by the bottom.
Okay.
Because it's a multiplication.
So in that case, okay, so if it's 1/2, you're really kind of just doing it on one of them. But if that wasn't the case, you would do 2 separate fractions, right?
No, it's multiplication. You see the multiplication case.
I got it. Okay, I got it. Never mind. I got it.
Yeah, if you have any doubt about it, it's going to be 6/34 first.
Yeah.
Then simplify it.
Got it. Okay.
Going to be, it's not a big deal. Or eventually you have to write down in percent. You can use your calculator right away and give us a percent answer. And that's done.
Okay, yeah, that makes a lot more sense. Thank you.
Okay. That's it. Any more question to get this one? That is going to be the case. It's not a cross multiplication, of course. It's just multiplying. You can simplify it and cross if you like. You can, since it's a multiplication, you can simplify anything from the top by anything on the bottom. The order is not important to get these numbers. Okay, any question? So it's very popular problem. Don't visit. You have a couple of them in your book and you see it in your practice one. And the formula is important for us. Okay, don't just give us 2 numbers. I've seen some people on the test. This is the way they do it. For the first part, they give you this one as an answer, 6 over 17, 8 over 17. And for the second part, they give me this answer. You see, that's exactly how they write it down. So you get 5 out of 10 over here. because you just give us an arithmetic. It doesn't make sense. Nothing to do with the probability. You have to give us a formula, okay, to find out how these numbers connected to the red and the green. You see, 6, 17, 8, 19 doesn't make sense. So write the formula. Write the formula to show that how you connect these numbers to your probability. Because that's important, because these two cases are multiplication rule. Multiplication rules for independent events, multiplication rules for dependent events. Okay, so it's not a difficult problem, but write it down correctly so that you get your points. Okay, but in a statistic, what they do, they like the first part, because when you want to continue, you see the first part can be extended into not only 2 events, 3 events, 4 events, 10 events, and this is what we need in future. In future, you may have 1,000 events, and in that case, you want to get the probability of getting all of them at the same time. So getting all of them at the same time, if it's going to be independent, you just multiply you multiply these probabilities together, which is going to be the case. You get the result right away. So what they do sometimes, they create something that if the population is going to be very large, really, if you talk about the population of the United States of America. So if your probability is a sample against the population, full population, which is very large, in that case, you can assume that everything is independent to get these numbers, because the difference is going to be very, very small, of course, if you have a large population. So they take care of it. That's why they like the first one all the time. So they impose some condition that's going to be, because that's much, much more practical when we get more events, and you will see it when we are going to extend it later on. Okay, so that is going to be the case. We have something, next chapter regarding the binomial distribution, but very much depends on this argument. So when you get to it, I will explain it again. But for the time being, this is all you can do. You cannot do anything else. Okay, any question? So we got all the rules of the probability that we need. Okay, we don't need anything else for the time being. Okay, there are some factorial notation and some counting formulas. We don't need it now. When we need it, we come back to it and we check it. That's because we are not going to use it. So that's why we go to the chapter 5, which is a quite interesting chapter. Okay, and we try to get chapter 5. It's going to be 2 parts, 2 different parts. We try to get, surely we get the first part before your next test. Okay, so let's get a little bit of that one too. Okay, so I think we have the next week. Your spring break is not next week. I think that's what would happen at Palomar. But at the university, we have the spring break next week. So we get the chance to get to whatever we need, and then we give you a practice. And then when you come back, I think from your spring break, we are going to have the test too. But I double check this to make sure you get it. Okay, this chapter 5 is quite interesting one. And it's going to be very useful for us. You see what we did so far. So that takes us to chapter 5. And that's going to be 5.1. It's going to be the kind of things that we are going to do for the rest of the course. That's the idea. You see what we did so far? We defined the probability for you. Okay, we get the probability and we focus on the events. Okay, so then event was given to you, and that is the event was given to you. Find the probability of those events. So we define the probability as a function, if you like. It's a function because it's a machine. You drop the event into this machine and you get the probability out. Since the event is a collection of outcomes, event is going to be a set. The probability is going to be called in algebra or in mathematics rather than a statistic. We call it a set function. A set function is a function that's defined on an event. So what else we can do is we can consider some kind of functions or probability functions that would behave like the one that you like in algebra. The function that you like in algebra is, you like it to denote it by f of x, okay? F of x equal to the x squared minus 3x plus 1. That's the one you like. And then you like to be able to substitute for x, okay? So what we are going to do in this chapter is, we are going to look into the probability as a kind of algebraic function. So we would like to talk about P of X rather than P of A. So this is the idea of this chapter. So we are going to define the probability function, but in statistics, they don't like to call it function. They call it probability distribution, okay? So that's why the title is going to be, what is probability distribution? Probability, okay, probability distribution. Probability distributions. This is going to be our purposes, okay? So I just recall that, if you like, recall that, yes, from algebra to know what we are talking about. Recall that if f is a function, with in algebra we say real variables, real variable x, then this is going to be the action of the function. What is the action of the function? You get the x, okay, we get the x, you drop it into the function. This is going to be your function. Your function is going to be kind of a machine, okay? So your function is like a machine, okay? And this machine, just using different color, okay, this machine would act on x and give you f of x. That's the one. In algebra, this is the one that you call it input. And this is the one you call it output. That's going to be your definition of a, okay, definition of y equal to the f of x, definition of a function in algebra. Okay, the function is a kind of cashier. Okay, can you give us an example of function in everyday life? If you have seen it. Okay, a Starbucks is a function. You see, when you go to Starbucks, you pick the eggs, cappuccino, then you go to the cashier. The cashier will charge you. So the input is going to be your order, the output is going to be $5 for this something that you're going to pay for it. So you drop the X in and you get the Y out. There is only one condition. The condition is for each X, you are going to have only one Y that satisfies this condition. Okay, it's so all the fast food restaurants are going to be function. Okay, grocery store is a function. If you pay your taxes, there is a formula to pay the taxes, is a function. You go to the post office, is a function because you put it on a scale and then they are going to charge. So this is a notion of the function that you have in algebra. In algebra, we say x is a real variables. Real variables means x can take any real number between negative infinity and positive infinity. And that would be the domain of the variable x. Now, what we are going to do is, that's algebra. So we would like to do something similarly in a statistic, okay? Similarly, if you want to do similar things over here, so we start with the x. This is going to be the x, but we are going to drop it into the probability function now. Probability function would be p. Probability would be p, and the result would be p of x. Now, what is the meaning of p of x now? The meaning of p of x means this is the probability of getting x. the probability of getting X. Okay, so it's a function conditions. The variable X, the value of the variable X, okay, the value that X can assume, all of them are depends on chance. Okay, that's why this is not going to be called in statistics a real variable. We are going to call this one a random variable. Random variable. Random variables means the outcome, the values that X can attain, if you like, it depends on chance. Okay, so officially now I'm going to define it for you, the probability distribution, if you like. So we need to define nicely X, because in algebra we know that this is a real number, but we want to know what you call it here. And then the P of X, the function part is the same as the function in algebra, okay? A function can be defined by an equation, a formula, by a chart, by a graph. Okay, so it's going to be the same thing over here. Okay, so that was a preview. So what's going to be the actual one? The actual one is we have to define what is a random variable, random variables that we use in a statistic. So it's going to be what? It's going to be an X, if you like, a random variable. Random variable. A random variable X, okay, random variable X is going to be, is a variable. It's going to be a variable that has a single numerical value. X can be equal to 1, 2, 3, etc. A random variable X is a variable that has a single numerical value. Okay, numerical value that would be determined by chance. Determined by chance. That's why we call it a random variable. Okay, it's going to be random variables. That is going to be the case. Now, we did this one right at the beginning of the course. Remember the discrete and the continuous variables that we talk about it? Discrete was dot, 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 the counting numbers. So if X can take 0, 1, 2, 3, 4, 5, 6, in that case, X is a discrete random variable. But if X can take any number, any real number, or any number in a given interval, in that case, it's going to be continuous random variables. Okay, just repeat it. You have some examples again in this part in your book. So it's very important to know if X, okay, if X can take counting numbers or natural numbers, counting numbers. This is means X equal to the 0, 1, 2, 3, etc. Then X is a discrete variable, discrete random variable. Okay, that's the case. Otherwise, if X can take any real number in a given interval, then X is going to be a continuous okay, it's going to be continuous random variables, random variable. Okay, so it's very important to know the difference between these two. When we define the function, you will see that we are going to divide them in two parts. The part that x is a discrete and the part that x is going to be continuous. And the course would be divided into two parts. Okay, so that's how we define our variable x. Any question? Now, how about the function? Let's define the function, we'll give it a break and we come back. So remember, when it's x discrete from now on, x can be 0, 1, 2, 3, 4, 5, 6. But when it's a continuous, it's going to be any real number between negative infinity and positive infinity. So it can be any real number, like the temperature. What's the temperature today? The temperature is between what? Between 32 and 86. So this means during the day, x can be any number in that interval. Okay. So let's define what the function means now. Probability function. Probability. Okay, as I told you, they don't like to call it function. They say probability distribution. Distribution or distributions. It's a kind of function, but it can be given in various forms. So there you are, a probability. A probability distribution. It can be, is a graph. Is a graph, because sometimes they identify by a graph. Remember histograms? Histogram is a probability distribution. A graph, it can be a table, formulas, or a formula. A graph, a formula, and that gives what? That assign number to the x that gives, or assign, in this case, that gives the probability. Gives the probability, and the probability of each value of x. Value that f of x, p of x is defined. That gives the probability of each value of the variable, of the given variable x. It's denoted by, it is going to be denoted by p of x. Like f of x, we say p of x. So as I told you, when we say p of x, this means probability of getting x. What is the chance? So the result must be given in the probability format, if you like. That's going to be the case. Okay, any question? Now, as we talk about it, if this x is discrete variable, this is called discrete probability distribution. If this x is continuous variable, this is going to be called continuous probability distributions. Okay, so let's finish this one. That we have two cases. So if x is discrete, if x is equal to the 0, 1, 2, 3, etc., is a discrete variable. Number of the cheeseburgers, remember, number of the cars in the parking car, this is the one, is a discrete variable, then p of x is going to be a discrete probability, a discrete probability distribution or function. Okay, so if x is discrete, if x can get only those numbers, we are going to have a discrete probability distribution. Otherwise means fx continuous. Otherwise, p of x is a continuous. It's going to be a continuous probability distribution. In this chapter, we only study the first one. For the rest of the course, we take the second one. Okay, so we make a note that in this chapter, up to your test 2, in this chapter, we study, okay, we are going to study discrete probability, okay, we study discrete probability distribution, only. So I emphasize again, so x is equal to the 0, can be 0, 1, 2, 3, etc. When you are out of the chapter, we are going to take the continuous one. There's going to be a nice story between these two, and we're going to discuss it. And that's it. We can give you an example, but we give you a breakdown first, then we come back. We're going to investigate it like in algebra. I'll give you a couple of examples to see how we're going to deal with this one and how it works for future. Okay, it's almost 11:26. 10 minutes, we come back and we try to get something more. There are 3 problems from this first part that we have to discuss, and we are going to get maybe a couple of them today. Okay, see you in 10 minutes. Okay, so let's have some examples. So this is going to be discrete probability distribution from now on. You see that we talk about it that it's going to be like a function. So the first question is going to be, is it like any function in algebra? For example, if I give you f of x equal to 3x plus 1, is that function can be also a probability function? The answer is going to be no. You know that probability would have some conditions. For example, probability cannot be negative. We know it before from the, okay, the previous part that we discussed. And so we have to impose those conditions that probability must be positive between 0, 1, and the probability of all the likelihoods, all the outcomes must end up with 1 or 100%. So before giving you this example, we remind you these conditions again. Okay, so this is going to be called conditions. Remind you again, and you have some problems on this one. Conditions for a probability okay, distribution. And probability distribution from now on, it's going to be that P of X that we talk about it. Okay, so make sure you have the following conditions. The first one, probability cannot be negative. Remember, the probability P of X is always between 0 and 1. Means it's positive and it must be less than 1. 0 and 1, you know that it's the same as 0% and 100%. So this is going to be true for any value of X, or any value of X. So if you were given P of 1 equal to the 1.5, you know that there is something wrong with this one. You're not going to accept it. And the second part is, if you add all the values of this function together, you must get 1. So use the notation sigma. Sigma of Px is equal to 1. Okay, so this is going to be where you are going to use all the possible values of X, where X assumes, okay, X assumes all possible values. Okay, so you add all the possible values together, and the result must be 1 or 100%. And that would form your first question, your first assignment that you have. Any question? So these are the ones we did before. So we remind you that we're dealing with the probabilities. So these are going to be the conditions satisfied. So what's going to be our first question? Our first problem. We give you the function. You are going to tell us whether this function table in this case. Okay, if the given table represents a probability function, a probability distribution, of course, not the function. Probability, okay, distribution. That's it. And this is going to be the first one. The function would be given to a chart, a table. So this is it. This is your X, the input. And this is going to be your P of X. It's like X and the Y that we write for the algebraic function. If X is equal to the 0, probability of getting X, probability of X equal to the 0, or P of 0, is 0.2, which is 20%. Then for 1 is given to you is 0.5, which is a 50%. For 2 is given 0.4, which is 40%. And for 3 is given to you as 0.3, which is 30%. Okay, check both conditions to see yes or no. This is the first condition, everything between 0 and 1. That's it, 0.2, 0.5, 0.4, 0.3 are all less than 1. So the first condition satisfy. The second condition, add them together. You see, add these numbers together. It's a 0.2, 0.5, 0.2, 0.5, 0.7. Okay, 7 and 4, 11. And 14 is going to be 1.14. It's greater than 1. So this is not a probability distribution. Okay, it's a function from algebra point of view, but it's not a probability. Okay, so this is the way you're going to answer it. Solution. You check, you see, I did check the first condition. Everything is between 0 and 1. Done. The second part, you add them together, sigma px is equal to, you have the 0.4, 0.5, 0.4, and the 0.3. You add them together, that give 1.4 is not equal to 1. Okay, so the answer would be no. P of x is not a probability. P of x is not a probability or probability distribution. Okay, this is the way you know you are going to check when you have a collection of this in your book to answer it. Any question? We don't usually go with the formula, but sometimes it may be given to you. So I just show you how we're going to take care of it. Okay, ready? I have to go to the next page. The second example. The second example is given as a kind of formula. You have the P of x equal to the x third. And you be told that x is 0, 1, and 2. So you have to form the table yourself. Okay, you substitute, you get these numbers first, solution. So you operate x equal to the 0, 1, 2, substitute in the formula. So P of 0 is going to be 0 over 3, which is 0. Okay, do you have P of 1? You substitute P of 1 would be a third. And then you have a P of 2. You substitute, we get the 2 thirds. Okay, so there you are. If you like table, you can write on the table. So for 0, we have 0. For 1, we get a third. And for 2, we get 2 thirds. The first condition is satisfied because the value of the function is 0, a third, and the 2 thirds. They are all positive between 0 and 1. And if you add the values together, 0 plus 1 third plus 2 third would be 3 over 3, which is 1. Okay, so we just noted that, yes, the first condition is satisfied. Everything is between 0 and 1. Then we get the second condition, the sigma of P of x. We add them together, we have the 0, a third, and the 2 thirds. So it's going to be 3 over 3, which is equal to 1. So the answer is yes. P of x is a probability. Is a probability. Okay, so if this is going to be given as a formula, it would be the same thing. Any question? Now we are going to give you notes. Sometimes we change the notation in a horizontal form. The P of X is the same thing. I just wanted to make sure you know it. I'm going to use this version because I save some space when you write it down. And it's the same in your book. So suppose this is the X and the PX. And they give you information in this format. When X is equal to 4, so we have 1, 6. When X is equal to 8, we have 3, 12. And when X is equal to 12, you get a half. And when it's a 16, you get 112. So that's the X and the Y. Then you want to check to see if it's going to be probability. The first condition is satisfied because all these fractions are less than 1. You have to add them together to make sure that the result is 100% or just 1. Okay. So the solution of this part again is going to be, we confirm that we check the first condition, everything between 0 and 1. So that's satisfied. Okay, we check the second condition. You have to find the common denominator to get this. Sigma of Px is equal to, we get a 6, 312, 1/2, and 112. The common denominator would be 12, so change all the fractions, change the denominators of all fractions into 12. So I multiply the first one by 2, the top and the bottom, so make it a 212. The next one is 312. I need a 12 here, so I multiply the top and the bottom by 6, 612. And I need and 112, yes, 1, 2, 3, 4, 112. So add the top together. 2 and 3 would be 5, 5 and 6 would be 11, 11 and 1 would be 12. 12 over 12 is 1. So the answer is yes, it is a probability. Yes, P of X is a probability distribution. It's going to be a probability or just a probability distribution. And be done. Okay, so this is how we are going to operate, and these are going to be the one that we are going to have from now on. Our new machine, if you like, to get these numbers. Okay, any question? Now, what is going to be the next step? So what we did, you see, we have a new environment, if you like. So we have the variable X, then these probabilities, when we put them together, then we are going to have a kind of new population, if you like, of these numbers. You have the new population of those values of X that you put them together. And you know that for each sample or these populations, in order to investigate it, we are going to be interested, or we would like to find the mean, the mean, standard deviation, and the variance. We did have a formula that we talked about it before, but we are going to modify our formula related to this new environment. New environment would be P of X, because the values that we got for the P of X would form a population for us. So we'd like to get the formula for the mean, a standard deviation, and the variance that would be involving this P of X, the probability of X. Okay, and these are going to be very interesting formula. So we are going to discuss what is going to be the mean, a standard deviation, and the variance of this probability distribution. Okay, so we modify those formula and nicely we get it. So this is going to be the next topic. And the next topic is going to be how we're going to find the mean. That's it. Mean variance. Mean variance and the standard deviation. And a standard deviation. Standard deviation. Standard deviation of P of X of this probability distribution they're going to have. Okay. So I'm going to work on the mean, show you how we connect, and then we go with the other two right away. Okay, so let's go with for the mean first. Mean. So for finding the mean of this, so the mean, we use the new notation. Notation that we used before was good for sample. Now we have a population, if you like, something larger. So from now on, we are going to use the following notation for the population. So the mean, okay, the mean of a probability distribution means the values that you get. P of X is going to be denoted, okay, it's going to be denoted by the notation, we call it mu. That's it, mu. Okay, it's just a Greek letter, okay, mu. This is the way I write it down. I call it mu. Okay, so the mean of a probability, mean of the probability distribution P of X is denoted by mu and is going to be defined or calculated, defined by this formula. You see mu is equal to sigma of x px. So remember that table that we have x and the px. We multiply all the possible x's and the px together, and then we add. That gives you the mean x px to get this one done. Okay. Now, if you want to know why, I'm going to show you why. That you just realize that we just modify what we did before. You see the modification is, if you want to stay with the first one, look at this one. It's nice to see, really. We don't ask you to prove, but it's nice. You see how we get this one. Note that in between there is something that we are going to use, give you one nice problem, which is not in your book, but we discuss it later. So let's see why we arrive at this formula. You see, note that this is the formula that we have for the mean. The case that we did have for the mean, the probability. Remember, when we have a distribution table, when we did have the classes and the frequencies, the way we talk about the mean, we get the midpoint formula and put something like fx divided by n. You see, if you remember, that was the formula. The formula was sigma of, we get the fx, that was f times x or xm, it doesn't matter. F times x divided by the total number of the frequencies. Okay, the total number of frequency, we usually call it n. So that was the formula that we did have before. Fxm divided by n. Now, if you break these two, it's going to be equal to the sigma of, keep the x, and just put the f over n. F over n. Let's see what is this one. You see f over n, f is the frequency. F is the frequency and n is number of the observation. Number of the observation is the same as total number of the frequencies. So f over n, there was something that we did before. The frequency of one class divided by total number of the frequencies. Remember, this was referred to as what? We refer to it as a relative frequency, f over n. And when we discussed the probability, we told you that there was three methods to find the probability. One of them was what? Relative frequency probability. So f over n, this f over n, this f over n, we are going to call it px. So the px would be f over n, and this is nothing but relative frequency probability. That's the one that we denoted by what? Denoted by percent. Okay, so this P of X, most of the time this is going to be the case. We're just using this formula to find the PX. And this is the problem that's missing in your book. Then you will see one of them when we go to the review. So this is going to be the one, so it's going to be P of X. So we just replace F of X by P of X. So that gives me what? That gives me sigma of XPX, which is the one that I talked about it. So that's going to be a kind of modification of this formula. In between, we learn something here. That in this formula, we can use the relative frequency probability that we did before. Okay, so that would be the mean. Any question? Sigma XPX added to your collection. You can bring it to the test and you need it. So that's a mean. We can do the same modification with the formula that we did have for the standard deviation and the variance, okay? So this can be done by calculator, but this problem was so easy that maybe that would be easier for you to just do it, because it's just going to be a couple of cases, couple of numbers, and I'm going to show you in a minute. You will see it's not a big deal. So the same modification which goes with the standard deviation and the variance. So we go with the standard deviation. The standard deviation. We did have a couple of formula for standard deviation, remember? But there was one of them that we call it computing one. That was given to you in the terms of the frequency. We are going to use the same one over here. Okay, so we have a special notation for this one. The standard deviation. Standard deviation of P of X is denoted by, the notation is called sigma, but this sigma, you see, sigma. This is the way I write it down, this is the way you may see it. Okay, but I write it down in this format, sigma, sigma, sigma. Okay, so the standard deviation of the P of X is denoted by sigma, and it's defined by, it's like the one that again we did for the standard deviation of the frequency distribution table. So it is going to be sigma. We can simplify it in this format, would be so easy to apply. It's going to be sigma of x squared px. X squared px, and then minus mu squared. Okay, it's going to be x squared px, then minus, minus mu squared. You know that the mu is going to be the mean that we're going to have. Okay, sigma squared is sigma x squared px, and then minus mu squared, then minus mu squared. I'm sorry, then we take the square root, of course, because this is a standard deviation. It's going to be a square root of this. Okay, and if you square it, that gives you variance. So the variance is going to be, so the variance is going to be sigma squared. We find the variance first. Variance of P of X is going to be denoted by, or defined by sigma squared. And we know that sigma squared is going to be just sigma of x squared px minus mu squared. We find the sigma square first, and then we take the square root, and that will give us the standard deviation. There's another formula for this one. It's in your book, but this is much easier to do it. So when you do it in your table, as we did it before, remember, we did something like frequency times the endpoint. Remember, fx squared, that was the one. It's exactly this one that changed it to the probability. And it can be done quickly, and I'm going to show you in a minute. Any question? So make sure to write this formula correctly and bring it to the test. We give you one question so far of these ideas, and this is the one. We are going to give you a probability distribution, and we ask you to give us the mean, the standard deviation, and the variance. Okay, there you are. You get one on this next test. So find the mean, variance, and the standard deviation. Standard deviation, the standard deviation of the given p of x, of the given probability distribution. Probability distribution. Okay, and this is the given probability distribution. I write it on this format to save some place. It's going to be x, px. And we'll be given that when x is equal to 0, your p of x is 0.125. When x is equal to 1, you have 0.375. When x is equal to 2, you have again 0.375. And when x is equal to 3, you have 0.125. You don't have to check it, it's already there, and it's already been checked. Okay, we need the mean standard deviation. Remember, as we did it before, in order to get the mean, you see the formula for the mean is sigma x px. And over here, you have a sigma x squared px, as we did it before. We are going to prepare the column for the x px, we add them together, and the column for the x squared px. So this is how you're going to do it. You're going to expand your table, and this is going to be your table. So that's your x, that's your px. You multiply these two together to get the xpx for the mean. And you multiply by another x to get x squared px for the variance. That's it. So for the x's you already got, repeat this: 0, 1, 2, 3. And the p of x is a 0.125. And that would be 0.375. The 0.375 again. And the last one is going to be 0.125. So make the first column. You multiply these together, you see. You multiply this together, that gives xpx, like the one that we did, 1. So I just write it down so you know what's going on for this one. So what I did, this is 0, which is the x, times it by 0.125. 0.125, this would be 0. Then you multiply by another x again. Okay, that would be 0 times 0, which is equal to the 0. So that's the first part. Okay, we do the same thing to the other ones. That's one. Again, it would be easy because 1 times 0.375. Okay, it's going to be 1 times. You don't have to write it down, of course. Just explain it. Is going to be 0.375. Again, you multiply by another one. You see, multiply another one, 0.75. So that give you the same thing. Okay, this one now is going to be changed 2 times. 2 times 0.375. That give you 0.75. And you multiply by another x, you multiply by 2 again, 2 times 0.75. And you multiply it, that give you 1.5. Okay, any question? This one you have to multiply by 3. It's going to be 3 times 0.125. Okay, that give you, it's going to be 3 times 125. So that give you 0.375. Okay, then you have to multiply by another 3. So it's going to be 3 times 0.375. And that should give you 1.125. Is it right? Or the last one? If you multiply 3 times 125, yeah, that gives you 0.375. And then you multiply by 3. 3 times 5 is 15, 21, 22. Okay, yes, that's correct. Okay, any question? Now the only thing you have to do is you have to find this addition of this column. That give you the mean. And you have to add these numbers to get the x squared px for the standard deviation. Okay, this number is also 0.375. Okay, so we get the 0.375, 0.75, 0.375. If you add them together, you must get 1.5. And over here, if you add these numbers together, you must get 3. Okay, so basically what you have is this is your sigma x px, which is 1.5. And this is sigma x squared px, which is equal to 3. Now we go to that 3 formulas and we get the result right away and we get that. Any question? It's like xf and x squared f that we did before for the frequency distribution table. Okay, so the conclusion is going to be following. The mean mu is sigma of x px, exactly this one, 1.5. So the mean is 1.5. Done. Okay, that's going to be your mean. You go with the sigma square first. Okay, get the sigma square. So this is going to be sigma squared. Sigma squared, the formula is sigma of x squared px minus mu squared. Sigma of x squared px is 3. 3 minus mu squared. Mu is 1.5. 1.5 squared. So that gives you 3 minus 225. Okay, it's going to be 3 minus 2.25. So the result is going to be 0.75. 0.75. Okay, just put it on the top. So this means sigma squared. Sigma squared is equal to the 0.75, which is going to be the variance. Okay, so this is variance. You take the square root, so that gives you the standard deviation. So the sigma is the square root of 0.75, If you use your calculator, I have 0.866. You call it 0.9. 0.9. So the standard deviation would be 0.9. So three numbers. Here we go to the 1.5. Sigma is going to be 0.9. And the sigma square is 0.75. Some people, they go directly to the sigma, but they ask for the variance too. So you have to find the variance sigma square, and you have to take the square root. That give you 0.9, and then you're done. Very nice, nice method. They usually ask an extra question regarding the mean. You know, the situation would be explain whatever it is. Then they ask you a question, whether they're not going to that question true or not. And that's it. We have one more important problem that we can get to talk about it from this section 5.1. There is something we call it expected value. Call it mathematical expectation, would be related to this formula. Mathematical expectation is that you are going to participate in an action that's going to be repeated over and over and over. So what's going to be your expectation? For example, you buy a lottery ticket every week. What is your expectation? Your expectation is to win, but you lose all the time. So there is a formula here, this mean here, that give you the average value that you're going to lose over the years. Like that's interesting because we have a couple of very interesting problems in everyday life that we can connect it. We give you that one next week, and then we continue, okay? But from this section, you need two more problems. One of them is not your book. I will bring you one. And the other one is just expected value. So we need something like half of the lecture again to continue to get it. So have a look at it. You know, it's going to be an easy case. And that's it. Any question? Take care. Yes, question?
Professor, I have a question about about our homework. I noticed
Yes.
that several of the sections are due on the 20th.
Mhm.
Are we allowed to go beyond that date, or?
Yeah,
Go ahead.
Yeah, you can ask for an extension.
Okay. Because I think some of them are due on the 20th, and we haven't gotten to that. Well, we might have just gotten to that section.
Yeah, I'll check it because those due times are automatically, you know, would be given to you. It's just a machine type.
All right.
So I may check it over the weekend. If it's going to be too many, I extend it, but you can ask for the extension. Then I will give you extension. You can ask as many extensions you like. But I'll check it. I'll check it over the weekend myself. It's going to be too many, then I change it. But otherwise, it's automatically, you know, it's just give you those due date. But nothing to worry about. Send me an email. I extend it as many as you like. Okay. Any more question?
I have a question.
Yes.
I emailed you about an extension for the last homework because the website was down.
Yeah, I do it over the weekend.
Okay, cool.
Yeah,
Thank you.
I checked it last night to see if that system is working. But over the weekend, I have your name.
Okay, thank you.
I'll give you the extension. I'll check the other one that, you know, Wesley was talking about it. And if that's the case, I extend those weeks. Don't worry about homework. Just ask for the extension. I give you those extension.
Okay, thank you.
Okay, have a good one. Take care. Bye-bye.